By this point in the semester, we've learned quite a few techniques of integration. U substitution, integration by parts, partial fractions, trig integrals, all that stuff. The question becomes, if I'm got some sort of random integral, which technique do I use? So that's a difficulty that a lot of people have, and it does help. Practice helps hugely. But we also have sort of a strategy that we can use kind of mentally to go through different things, classify the integral according to what it looks like, and figure out what to try first. But also remember, with integration, sometimes what you try first ends up not being the right thing, and you have to go back and try something again. It happens. All right, so here's the general strategy that you might want to use when faced with some sort of integral that you don't know what to do with. So, if at all possible, simplify the integrand. So just a little bit of algebra sometimes, or maybe if you see some obvious trig identity that might make things easier, go ahead and try that out. Then the first thing I always do after seeing if I can simplify is look for an obvious substitution. So a U substitution is what I'm thinking, right? Substitution. So what do you do when you're looking for that? You're looking for something to be your U, and then something that's going to be your du. So you're looking for that pair of a function in there and its derivative function. So if you don't see that, or if you can't get that to work, the next thing to do is then classify your integral according to type. So you've got a couple of things that you can do with your integrand, right? And this is basically mentally going through all of the things we learned in chapter 7 and seeing which technique is the one that makes the most sense to start out with. So, and these are in no particular order. If I see a bunch of trig functions, then I'm going to try to use the stuff from section 7.2. Right, where we try to use some trig identities and then make a U substitution. If I have rational function, then it's partial fractions. And I'll put, just for the, that was in 7.4, right? If I have products of two functions, of two different kinds of functions, so x times e to the x, something like that, that would be integration by parts, which, if you recall, was section 7.1. And then, of course, if I have one of those square roots, so a squared minus x squared, square root of x squared minus a squared, and then square root of x squared plus a squared. Those are my three possibilities. This is trig substitution. Now, by the way, sometimes you will also see, though I won't give it to you in this class, something with a radical that doesn't have a square under it. There's some other substitutions that work for that. Rationalizing substitution, which we didn't do. We skipped that as part of the curriculum in this class because it doesn't come up that often in applications. If you see something like that, you can just use a table of integrals or look up rationalizing substitutions, but you're never going to see it here because we just sort of skip those. Okay, so if you've done all that, and or you've chosen one of these, you tried it out and got stuck and can't get further, made your problem worse, you have to go back and try again, right? So say that didn't work. Step 4 is try again. All right, that's not a very helpful step, right? But okay, if it doesn't work, what else should I try if I've tried something and it didn't work? So, or if something doesn't seem to fit very well into one of these bins, like maybe inverse cotangent, right? What the heck is that? Well, if you don't know what to do, integration by parts is something you can always try. And if you already tried integration by parts, you might go back and try integration by parts with a different choice of u and dv. Also possible. You might try some fancy substitution. Okay. What do I mean by a fancy substitution? Oh wait, not that fancy, but like on the last worksheet, we had some where you did first like a u substitution with sine or e to the x or something, and then that turned it into something that you could do one of these with. That's the kind of thing I'm thinking of. Multiple techniques, which also is one of these. Would be use several methods. Sometimes you can use a substitution of a trig identity, substitution of some kind of something a little bit more unusual to get it into a form where you could do another method. Another thing you might want to try possibly is manipulating the integrand. So meaning sometimes multiplying top and bottom by something weird that will get you something nice. I'll do an example in my next video. So these are just some ideas. And also, in general, I wouldn't give you one and ask you to do it, but there are actually integrals that you cannot evaluate. Of course, you cannot evaluate them. You cannot evaluate them this way, right? You have to evaluate them numerically. So part of what we'll be talking about later this week is evaluating integrals numerically, but some integrals do not have an elementary antiderivative that you can just figure out. So you can be in the wide world of things, you can be aware of that for sure, but I'm not going to ask you to evaluate an integral that isn't doable. So